The idea that our universe is a cosmic cell within a larger living superbeing has prompted speculation about the nature of existence and reality in philosophical and scientific circles. This concept implies that our universe is not only part of a larger structure, but also has characteristics similar to biological systems, suggesting that there is interconnectedness and hierarchy in the cosmos. The notion of our universe as a cosmic cell raises intriguing questions about the nature of life and consciousness on a universal scale. If we consider that just as cells are the building blocks of life, perhaps our universe serves as a fundamental unit of a larger, intelligent existence. This perspective prompts an exploration of how the laws of physics and the principles governing the universe may reflect an overarching underlying order or purpose. Such a view can unify the concepts of cosmology and philosophy, inviting dialogue about the meaning of the purposefulness of the cosmos. Furthermore, this idea could lead to the study of how interactions between different cosmic cells occur. Just as biological cells communicate through chemical signals or electrical impulses, different universes may interact or influence each other in ways we have yet to understand. Theories of physics, including theories of quantum entanglement or parallel universes, can aid in this exploration by suggesting that connections between our universe and others may exist within metaspace. The concept of our universe as part of a living superbeing may also reflect the structures that govern universes, just as biological systems maintain homeostasis and respond to environmental changes. The properties of dark matter, dark energy, and the observed acceleration of the expansion of our universe may signify an awareness or adaptation mechanism, hinting at a dynamic, evolving cosmic system. Ultimately, while the idea that our universe is a cosmic cell within a larger living organism remains speculative, it encourages an interdisciplinary approach to questions about our existence. This invites scientists and philosophers to think about the broader implications of the complex tapestry of the universe and our place in it, pushing us into deeper discussions about consciousness, interconnectedness, and the nature of existence itself. As our understanding of the cosmos evolves, such fantasy concepts can expand our quest for knowledge, inspiring us to explore and investigate the deeper mysteries of life in the universe. The concept of cosmic DNA, which encodes the properties of different universes within a multiverse, is a fascinating metaphor for understanding the underlying foundations that may govern different realities. Just as DNA carries the genetic instructions that determine the characteristics and functioning of living organisms, this idea suggests that there may be fundamental principles or codes that dictate the properties and laws of different universes. In terms of physical theories, cosmic DNA may represent a set of variables or constants that define the distinctive characteristics of each universe in a multiverse scenario. Among these variables may be fundamental forces, particle masses, the force of gravity, and the nature of dark matter and dark energy. Cosmic DNA, by revealing basic rules and initial conditions, can provide a systematic description of how universes branch out or differ from one another. One way to approach the idea of cosmic DNA is through the lens of string theory and its many solutions. In this case, there is a wide variety of ways to compactify extra dimensions, each resulting in its own configuration of physical laws and constants. In this sense, the different compactification schemes can be thought of as separate genomes, each encoding the unique behavior of the universe. Consequently, the properties observed in our universe, such as the values of physical constants, may be determined by the particular structure of this cosmic DNA. Another consideration relates to the potential role of quantum mechanics in shaping the concept of cosmic DNA. Some interpretations of quantum mechanics suggest that each quantum event creates branches of reality, leading to divergent outcomes across multiple universes. The rules governing these events and their interactions may constitute another layer of cosmic DNA, where the nature of quantum phenomena dictates the evolution and properties of each universe in the multiverse. Furthermore, the idea of cosmic DNA begs the question of how interactions between different universes might occur. If each universe encodes its own set of physical laws and unique characteristics, Could there be pathways or connections facilitated by common structures? This suggestion echoes theories related to wormholes or higher dimensional pathways connecting universes, and suggests a more intricate network of interconnections in the multiverse. Ultimately, the concept of cosmic DNA serves as a compelling metaphor for exploring the fundamental principles that may determine the nature of reality in multiple universes. While researchers continue to probe the boundaries of theoretical physics and cosmology, this idea prompts deeper reflection on how the rules of existence may manifest in different ways, shedding light on the complex tapestry of the cosmos and inviting further exploration into the very fabric of reality itself. The concept of the expansion and contraction of universes as part of the cosmic cycle of breathing is a fascinating idea that likens the cosmos to a living, breathing organism. This concept suggests that universes undergo a rhythmic sequence of expansion and contraction, similar to the processes of inhalation and exhalation in biological organisms. Such a model could provide a compelling framework for understanding the dynamics of our universe and the possible existence of others. In the cosmic breathing model, the expansion phase may refer to a period of energy dissipation and growth due to the initial conditions after the Big Bang. At this point, the universe is stretching, galaxies are moving apart, and cosmic structures are evolving. This is consistent with our current understanding that the universe has been expanding since its inception, as evidenced by observational evidence such as the redshift of distant galaxies. Conversely, the contraction phase may represent a time when gravitational forces begin to dominate, pulling matter back together. This stage could lead to a major crisis when the universe collapses into a singularity, possibly starting a new cycle. In this way, the universe can move from a state of expansion back to a state of collapse, reminiscent of the exhalation process in which air is exhaled and then drawn in again. The concept of cosmic breathing raises intriguing questions about time, space, and the nature of existence itself. If there are multiple universes and they follow similar cycles, it could mean that the life cycles of the different universes are somehow interconnected. The rhythmic process can be applied not only to our universe but also affect other realms within the wider multiverse, with cycles of expansion and contraction leading to different properties and conditions in each universe. In addition, this model allows us to elucidate the role of dark energy and dark matter in the cosmic breathing cycle. Understanding how these components affect the dynamics of expansion and contraction can provide deeper insight into the mechanics of the life cycle of the universe. If dark energy continues the accelerated expansion we are currently witnessing, it could play an important role in determining whether the universe will eventually shrink or enter a new phase. Ultimately, the idea of cosmic breathing serves as a suggestive metaphor for the evolution of the universe and the possible existence of other cycles beyond our perception. As scientists explore the implications of this concept and investigate the dynamics of cosmological expansion and contraction, they may open the way to understanding fundamental questions about the nature of reality, the existence of multiple universes, and the deep connections that may unite all forms of existence in the cosmos. The concept of inter-universe synapses offers a fascinating framework for understanding how communication or energy transfer can occur between different universes within the multiverse. This metaphor suggests that just as biological synapses facilitate communication between neurons, allowing information to flow within a complex nervous system, inter-universe synapses may serve as conduits that enable communication between different realities. One potential mechanism for these inter-universe synapses is based on the idea of higher dimensions or hidden dimensions that go beyond the familiar three dimensions of space. Theoretical frameworks such as string theory suggest the existence of extra dimensions that may provide connectivity between parallel universes. In this context, synapses may represent pathways or bridges that connect structures of higher dimensions, allowing matter, information, or energy to travel between universes. These inter-universe synapses can manifest as gravitational or quantum entanglement links between particles or energy fields located in different universes. If particle states are entangled in different universes, an interaction in one universe can instantaneously affect corresponding states in another universe. This could provide a mechanism for information exchange or coordination between systems that, according to classical physics, would be completely isolated from each other. In addition, the concept of inter-universe synapses may include exotic forms of matter or energy, hypothetical particles that may not exist in our universe but reside in others. These particles could facilitate the transfer of energy across the multiverse, perhaps allowing the exchange of resources or physical properties. This idea prompts thoughts of new forms of physics and the possibility of using these entanglements to understand the fundamental laws governing each universe. The study of such inter-universe entanglement could also lead to intriguing discussions about the implications for cosmological principles such as conservation of energy and information. If communication and energy transfer were possible between universes, it could change our understanding of how these laws work when viewed in the larger context of the multiverse. This could breathe new life into fundamental questions about the nature of existence and inter-universe relationships. Ultimately, the concept of inter-universe synapses offers a rich history for exploring theoretical connections between universes and encourages deeper thinking about how the multiverse might function. As scientific research continues to push the boundaries of our understanding, ideas like this can inspire new models of reality that expand our understanding of the cosmos and the potential for interactions between its many aspects. The idea that dark energy may be the result of our universe being digested by a larger cosmic organism provides a fascinating and imaginative framework for understanding the dynamics of the cosmos. Dark energy is now recognized as the mysterious force that drives the accelerated expansion of the universe, accounting for about 70% of the total energy density of the universe. Such a concept suggests that dark energy may not just be a force or constant, but a sign of something deeper and interconnected to a larger living entity. If we consider the possibility that our universe is part of a cosmic organism, intriguing questions arise about what it means for one universe to participate in such a biological process. According to this scenario, the accelerated expansion caused by dark energy could be akin to metabolic processes where the universe is being transformed or utilized by a larger cosmic entity. It could mean that as our universe expands, it gives energy or information to this larger entity, becoming part of a larger system that affects not only itself, but other regions or entities as well. This metaphorical digestion can also explore the relationship between different parts of the cosmic environment. Just as biological systems maintain homeostasis, a cosmic organism may monitor the balance and interaction between different universes or cosmic structures. The properties of dark energy that affect the rate of expansion may point to a mechanism by which energy circulates or exchanges with a larger entity, suggesting a dynamic, interdependent relationship. This idea could fundamentally change ideas about dark energy and the universe. Suggests that cosmic evolution may involve more than just physical processes, introducing the idea of purpose, intentionality, or even conscious influence on cosmic dynamics. If dark energy is a byproduct of a larger organism interacting with our universe, this could mean that the expansion of the universe is part of a larger strategy for growth, evolution, or maintaining balance in the cosmic ecosystem. Ultimately, while the idea that our universe is being digested by a larger cosmic entity is speculative, it opens up broad philosophical and scientific possibilities for discussions about the nature of existence and the interconnectedness of all things in the cosmos. Such a perspective could inspire a new search for what cosmology and biology may share at deeper levels, encouraging us to rethink the traditional boundaries that separate life, energy, and the universe itself. As scientists continue to explore the mysteries of dark energy and the structure of the cosmos, they may discover ideas that connect these fantasy concepts to rigorous scientific research, expanding our understanding of the universe and our place in it. The concept of probability waves is closely related to quantum mechanics, where particles do not have a definite position but exist as probabilities described by wave functions. These probability waves can propagate through space and time, suggesting the possibility of different outcomes and states coexisting until observation leads the wave function to a particular outcome. If we consider the edge of our universe or the edge of the observable cosmic horizon, the concept of probability waves becomes particularly intriguing in its implications for the formation of new realities or universes. At the edge of our universe, these probability waves may represent the uncertainty inherent in quantum phenomena, allowing for fluctuations that can lead to new configurations of matter and energy under certain conditions. This idea is consistent with the theory of cosmic inflation, which suggests that tiny quantum fluctuations in the early universe led to the large-scale structure we see now. If such probability waves can create diverse regions of space with different properties, the possibility arises that they can initiate processes that give rise to entirely new realities or realms of existence. These probability waves may also suggest mechanisms for the emergence of parallel universes, as described in the many worlds interpretation of quantum mechanics. In this framework, each quantum event gives rise to branching realities in which each potential outcome occurs in its own separate universe. If the edges of our universe are permeated by probability waves, the interaction and collapse of these waves can lead to the creation of new branches, contributing to the existence of alternative realities that evolve from different paths of quantum events. In addition, the dynamics of probability waves can affect how components of our universe interact with hypothetical structures or spaces beyond the boundaries we observe. For example, if probability waves propagate from our universe to areas that we cannot observe directly, they may establish connections that facilitate the exchange of energy, information, or even matter with other realities. Such interactions may play a role in the evolution of these new realities, perhaps allowing them to utilize the fundamental properties of our universe while developing their own unique characteristics. While researchers continue to explore fundamental aspects of quantum mechanics and cosmology, studying probability waves at the edges of our universe can provide insight into the complex relationships between different realities. This research not only challenges our understanding of the nature of reality, but it is also suggestive of the interconnectedness of all things, potentially expanding our view of the universe and the myriad possibilities that can arise from its inherent uncertainty. The idea that our universe may be a cosmic hologram projected from a higher dimensional reality is a fascinating hypothesis that combines concepts from quantum mechanics, theoretical physics, and cosmology. This notion is based on the holographic principle, which states that all information contained within a volume of space can be represented as a two-dimensional surface, suggesting that the three-dimensional experiences we perceive may arise from information encoded at the boundary of lower dimensions. If our universe is indeed a hologram, this means that the structure of reality as we know it is fundamentally different from our intuitive understanding. In this concept, the vast three-dimensional universe we experience may be a projection of information located in higher dimensions. This could imply that the underlying reality is more complex and interconnected than we currently realize, with higher dimensions serving as the basis for the physical phenomena observed in our universe. Exploring the concept of the cosmic hologram raises tantalizing questions about the nature of existence and the relationship between reality and perception. If our universe is a projection, this suggests that our perceived laws of physics and constants may simply be a reflection of deeper underlying principles. This could lead to a re-evaluation of fundamental concepts such as time, space, and even causality, as they may be emergent properties rather than fundamental aspects of existence. Moreover, if this holographic projection comes from a higher dimensional reality, it implies that there may be additional dimensions influencing the behavior and interactions of particles and forces in our universe. This could provide a basis for exploring the connections between different scales of reality, perhaps connecting the quantum domain to cosmic structures. The nature of dark matter and dark energy may also be reconsidered in this context, as they may be manifestations of higher dimensional effects rather than independent entities. The synchronicity of information encoding in a holographic universe may also have profound implications for our understanding of black holes and entropy. The work of physicists Jacob Bekenstein and Stephen Hawking on the thermodynamics of black holes suggests that the information content of a black hole is proportional to its surface area, which is consistent with the holographic principle. This raises deeper questions about how information, energy, and the fundamental nature of black holes intersect with the wider cosmos if our universe is indeed a holographic projection. In conclusion, the idea that our universe is a cosmic hologram projected from a higher dimensional reality forces us to rethink deeply held notions of existence and reality. Researchers continue to explore the implications of the holographic principle and its relationship to fundamental physics. Such a perspective could lead to revolutionary discoveries, expand our understanding of the universe, and perhaps reveal a more complex tapestry of reality than we currently perceive. The concept of quantum foam wormholes arises at the intersection of quantum mechanics and general relativity theory, suggesting that at the smallest scales, particularly at the Planck level, space-time is not smooth and continuous, but instead exhibits a frothy, fluctuating structure. This idea suggests that the fabric of the universe is made up of tiny, ever-changing bubbles or foams that can create transient connections or tunnels between different points in space-time, potentially linking our universe to others in the multiverse. At the heart of this concept is the notion of wormholes, theoretical passageways in space-time that can connect distant regions or even different universes. Quantum foam suggests that these wormholes may exist in a fluctuating state on incredibly small scales, effectively connecting the dots in both our universe and possibly other parallel universes. Rather than being stable structures, these wormholes could arise and disappear, appearing momentarily when quantum fluctuations occur. These transient connections may facilitate communication or interactions between universes, allowing the exchange of information, particles, or energy across the boundaries of different realities. Such interactions may not be observable in the traditional sense, as wormholes would only exist for a fleeting moment, emphasizing the probabilistic nature of quantum mechanics. Moreover, the chaotic nature of quantum foam may mean that although these connections are ephemeral, they can have a significant impact on the dynamics of the universes involved during their brief existence. The implications of quantum foam wormholes extend into the realm of information theory and the study of holographic principles. If information is fundamentally linked to the structure of space-time, as the holographic principle suggests, then these tiny connections could be the key to understanding how information and energy are transferred at cosmic scales. The researchers suggest that studying these connections could help clarify the behavior of dark matter and dark energy, which remain enigmatic components of our universe. In addition, the existence of these wormholes could offer alternative explanations for some quantum phenomena, bridging the gap between the macroscopic and microscopic worlds. They suggest that the behavior of particles is not limited to the three-dimensional space we are familiar with, but may involve complex interactions with higher dimensional structures or neighboring universes. In conclusion, the idea of quantum foam wormholes connecting our universe to others on the smallest scales represents an exciting frontier in theoretical physics. As researchers delve deeper into quantum mechanics, general relativity theory, and the nature of space-time, studying these wormholes could unlock a deeper understanding of the interconnectedness of the universe, helping to unlock the mysteries of existence and the potential for interactions between different realities. The idea that the natural constants in our universe may be determined by a cosmic evolutionary algorithm provides a fascinating model for understanding our universe's intrinsic features and their origins. This concept suggests that fundamental constants such as the gravitational constant, the speed of light, and the fine structure constant, rather than being fixed or arbitrary, those configurations that promote stability, complexity, or conditions favorable to the development of structures such as galaxies, stars, and ultimately life can be selected to characterize our universe. Such an algorithm could operate in a multiverse where there are countless universes with different combinations of physical constants. Within this multiverse scenario, some universes may undergo different evolutionary processes driven by the interaction of constants, with certain combinations proving to be more favorable for complexity and stability. Over time, this evolutionary filtering could increase the likelihood of universes possessing the balance of forces and structures necessary for the emergence of life and consciousness. The implications of the cosmic evolutionary algorithm extend not only to the constants of nature, but also to the fundamental laws of physics. If these laws can be regulated or can fluctuate within this algorithm, it suggests that our universe may be the product of a continuous dynamical process rather than a fixed endpoint. This could lead to a deeper understanding of how the laws governing quantum mechanics, gravity, and other fundamental interactions might interact to create a complex universe capable of evolving over time. Furthermore, such a perspective challenges our understanding of fine-tuning, the apparent precision with which the constants of nature enable life and complexity. If the constants are the result of a cosmic evolutionary process, this raises profound questions about the nature of life itself and its relationship with the cosmos. Life, in this view, becomes an important factor in the evolutionary algorithm, potentially influencing how constants are set or changed in neighboring universes. Ultimately, the concept of a cosmic evolutionary algorithm opens up a wide range of research opportunities in cosmology, physics, and philosophy. As researchers continue to explore the foundations of the universe and the nature of physical constants, this idea prompts deeper reflection on the interconnectedness of existence, evolution, and the mysteries of the cosmos, paving the way for new insights into our understanding of reality. The concept of reality fractals offers a fascinating scheme in which the structure of the universe exhibits self-similar patterns at different scales, leading to the idea of infinite nested universes. Fractals are mathematical constructs that exhibit repeating patterns at different levels of magnification, so that smaller sections of the fractal resemble the whole. Applying this concept to cosmology suggests that the universe may not only have similarities in structure on large scales, such as galaxies clustering into filaments, but also duplicate configurations on increasingly smaller scales, potentially leading to the existence of nested universes within a larger cosmic structure. In this model, each universe can be viewed as a fractal, with its own set of physical laws and properties formed from similar underlying principles. Large-scale structures, such as galaxy clusters, may retain features that point to the same principles that govern. Moreover, the idea of nested universes has intriguing implications for our understanding of quantum mechanics and particle behavior. Quantum phenomena may also exhibit fractal-like behavior, suggesting that particles interact with each other and with their environment through self-similar mechanisms operating at different scales. It may lead to the idea that the fundamental processes governing the behavior of particles are inherently linked to a larger cosmic structure. The concept of fractals of reality can also challenge our notions of time and sequence in the cosmos. If the structure of reality is based on fractal principles, it may mean that different layers of being perceive time differently or even influence each other. The interconnectedness of these layers may allow for unique interactions that span universes, further enriching the complexity of reality. Ultimately, the idea that the fractals of reality create infinite nested universes provides an opportunity to explore the interconnectedness of structures at different scales. As scientists continue to explore the nature of the cosmos, this concept may lead to innovative theories and models that will contribute to a deeper understanding of the fundamental principles that govern existence. Such research could reveal not only the nature of our universe, but also the nature of reality itself, changing our view of the cosmos as a whole.